Hello, everybody. I thought of recording this session and give you because once I conducted this session, there were only few students. So now you can go through this recording and also through the book and understand what you need to learn from this session. So let's talk about manufacturing today. Here, I wanted to tell you about the design process. So, we will, our course is computer aided design and manufacturing, and first step, designing. So, traditionally, what we do in designing, we think of what we have to do. So, we identify the problem. Doing various analysis, we identify the problem, or I can and we put it into a model, or kind of in easy terms. Like if I say we want to design something, and we put it on a paper, draw it as a sketch, so that we can understand easily what we want to design. So next stage is we are going to improve the design. So for that, just think of, for an example, we want to design a table to keep or a computer table to keep your computer. And what we do, we put our idea on a, as a sketch on a paper. Then we will apply, we have say we want to keep the computer on the table, and we roughly take the mass of computer CPU and the monitor, and we will see whether the table is strong enough to hold that weight. So we will calculate how strong, or the strength of the table should be. So after that, I mean, say if this is the tabletop, we can apply load here and load here at various positions and see the strength of, or the load carrying capacity of the legs. So actually we are designing legs and the tabletop. So after that, we need to optimize. And optimization means we are trying to reduce the material usage. If this is a tabletop, we can see, we can identify optimum thickness of the tabletop. So we can apply loads here and see whether the tabletop deflects. Also, the same way we can use design analysis, and we get from the design analysis we get some dimensions for legs, and we can optimize again to reduce the material of legs. Maybe we can make it hollow, or we can make it solid, and we can change different diameters, or the if it's a round one, we can think of diameter and thickness of the tube, or if it is square one, we can identify it, so it should be a solid one, or it should be a hollow one, according to our load. So this is an iterative process. That means we will analyze, optimize, and redesign. So here what we do, we are our idea, we are refining and make a new design, a final design. And after all, we can put it into documentation. That means you put it your in your sketch, or you make a design, engineering design, with dimensions, so that from that dimensions, that diagram, I call it engineering drawing, we start manufacturing or fabricating. So that this is the traditional process of designing, and let's see how we can improve it with the computer. So again, these are the basic steps, like we identify the problem, we we put it into a computer model. We design it, we draw it using CAD, computer design software. We model it on a computer. So after that, on computer we can do the same. We don't have to do manually now. We can use software for designing calculation process. So we do analysis part, we call FEM analysis, or computer engineering design analysis part. And we can do again here, this is combination of design, analyzing and optimization, and we feed it to our traditional design process. Actually the traditional design process is used, but we are getting aid of computers. So this is what we mean computer design. So again, we get the problem idea, and we will design, analyze, optimize, or evaluate. In design process we did evaluation, that means these two parts, analysis and the optimization. And we these are like using different terms, but we said it's documentation. Here it's, I'm using presentation. So we here is the final engineering drawing you get with the dimensions. So this part is done by computer. So this is the computer design process. So just remember how the computer design, or the like traditional design process, can be improved by computers. Now we will see the terminology, or the definition of manufacturing. So manufacturing is actually conversion of raw materials into tangible products, that means usable products. So manufacturing is can be defined as value added, or the value addition process to raw materials or components or the parts, whatever, and make a finished product which can be used. So for this we are using various type of machines and various processes, and we need energy for all these. So remember, the term manufacturing can be defined in various ways. So briefly we can say manufacturing is a process of converting raw materials or components or parts into finished product using various methods of process and energy. Also in manufacturing there's a supportive part, we call it manufacturing support function. So yeah, manufacturing support functions. So in that we have sales, management, marketing, like transportation, everything goes into manufacturing support. So this is the usual process. So here we start with the raw material, and we do within the factory. This considered as a factory. We can do processing, assembly, material handling, inspection, testing, various process, and process are controlled by human or the whatever the computers, and we get the final product as output. Manufacturing and production, these are two different terms, but usually it gives same idea, but correct definition is different. So production is a process converting inputs into outputs through various operations or processes. So in manufacturing, we start with raw material and we convert it into output products. In production, we say we start with whatever the input or the components, assemble and make it as a finished product. So in broadly, if you look at this term broadly, production is the broad term and manufacturing is under production or the part of production. So we can say all sort of manufacturing falls into production, but production is not fall into manufacturing. So read more about these two definitions and understand what does it means. So there are four type of, we can classify manufacturing into or the production into different classes, or we can say classes of manufacturing or types of production, thinking different aspects. So if you consider about the volume, manufacturing volume, parts volume, that means how the quantity of the parts to be manufactured. In that aspect, we can divide into different classes of manufacture, different classes or the different types of production. So this is considering the volume, production volume. So first class is job shop production, that is very low level or low volume. That means only one or two, three kind of very few parts to meet customer order. So we produce one or two part or maybe one part specially required by customer, so custom product. And in batch production, or it is medium size lots, maybe 10, 20 like batches, batch of 10, batch of 20, batch of 30, likewise different productions. And next class is mass production. So here the production volume is high, in maybe in a, like say a manufacturing factory or the facility. Here this type of manufacturing makes only one or two product on each design or each type. In batch production company or the factory, they make different products in batches. In mass production companies, they produce only the same type of part or the product in a high volume. So next is continuous flow of process. That is continuously start. If you start from the raw material, it continuously process to get the output product. This type of operations are like we can say oil, sugar, uh, or different like processing rice, kind of that type of, say for instance, sugar manufacturing plant from cane, white cane, sugar canes. You get extract juice and solidify, and you like bleach it and kind of making powder or and filtering, that kind of process. It's a continuous flow of process. So in our course we will talk about these three type of productions. I'm sorry guys, there's a lot of background noise here. Just don't concentration on the background noises, so just think of what I'm saying. So this is how production or manufacturing classify according to volume of production. So for every product there is a product life cycle. That means from the starting or the start and end till, say if a cell phone, from the fabrication process and until it declines, it lifetime ends. So we can divide it into product life into 4 sessions, like introductions, growth, maturity and decline. Actually this can be this is considering from sales. Here we can include the manufacturing time, design time, everything. So in under this introduction it is included manufacturing and design time as well. So what we do here, as we discussed earlier, we do the design process and we send it to the engineering drawing to manufacturing, and in manufacturing there are again manufacturing support systems like sales, marketing and all. So to introduce a product to the market, it takes it takes little time, and while that time from 0 to sales start growing, and here after introduced to the market, like this part is like introduction to the market. So once you introduce to the market, it will rapidly people will start buying it rapidly, so sales goes high. So this is we call growth. And after some time, once people started buying, then again it goes to a peak and people stop using it, because maybe in the market there will be a new product, so they reduce by purchasing that part, and slowly it goes to decline age, so the end of life cycle. So you cannot sell products anymore after some time. So this is the product life cycle, and you remember these categories, like what are the categories of product life cycle, and read these as well. Earlier we came to know type of, or the classes of manufacturing, or the type we can call classes of manufacturing, we call it type of manufacturing or production systems. We use different terms, but this is what I, as I said, the production is classified according to product volume. So as I said, here it's in this diagram, it shows product quantity and product varieties. So you know the term varieties, like different parts or different products, and here product volume or the quantity. So this diagram shows how product quantity and product variety changes with type of manufacturing. In job shop product, it is not various product. Here they produce various products, like maybe say for an example, pen, pencil, eraser, like that, maybe one or two products, as I said before. So the product variation is high and the product quantity is low. In mass production, here we produce same type of product, so product variety is low and product quantity is high. And as I say, in continuous product, it's same kind of product continuously changing the product kind of process product from raw material to finished product. So in this type, it's same type, so the product variation is zero actually, or the very slow, and product quantity is high. So remember this as well with the definitions and categories. This is the same. You go through these slides. This is the same that I introduce you. This is also just to brief you the difference between the production and manufacturing. Go through this as well. Here it just shows manufacturing falls into production. So production is actually divided, is the can say the it's production is the broader view of manufacturing. Again, as I said before, a production system can be categorized into two: manufacturing systems, here facilities, factory equipment, and manufacturing support systems. So here basically you get inputs and we use resources like human resources, energy, those type of, and people, machinery, they all together start converting raw materials into finished products. Again, this shows the what a manufacturing system is. Now you know the term manufacturing. This is how manufacturing, the whole factory, we can consider as a manufacturing system. Or there will be different kind of products manufactured in a factory. Again, maybe this plant, we can call this as a plant, like manufacturing pens, and in other plant manufacturing pencils, likewise. So just want to show here, you can start with the raw material, equipment, tooling, fixtures, also type of tooling, and labor or human resources and energy. All these together work and output the product. Also there will be an output, the waste. So in modern manufacturing, we are trying to reduce this part, and here we are trying to accelerate the production time. So that's why basically we need CAD CAM. Again, this is functions in manufacturing systems, like post processing material, then assembling part, material handling, then after completing the part, inspection, testing, and factory control. So these are some examples for manufacturing systems. There are single station cells, machine clusters, assembly lines, transfer lines, flexible manufacturing systems. We will talk about these terms later. For now, you just remember these are different type of manufacturing systems. So I'm back in this slide. This is the definition of computer aided design, or CAD. So the basically CAD, computer design, it's done by software. Please read objectives of CAD in your book. And so far, remember, CAD is used as a integrated software system to create, modify, analyze. Here, if you see here, we will create geometry or the model by using CAD software, and we will redesign everything we can do here. That means like create, edit, modify, all. And next stage is analyzing. We analyze the design and optimize. So CAD, we have 2D CAD systems, 3D CAD systems. We will talk about next sessions about that. Here you understand the importance of CAD, or using computer designing. So it helps to increase productivity, improve design accuracy, and improve this. Here we have, I told you, this is an iterative process. So here by CAD can reduce time to redesigning. So the software facilitate redesign iterations, and mainly you can visualize the object, so easy for design. So that is what is done by CAD. in your book, read objectives and benefits of CAD systems. If I brief you the benefits, it is enhancement, designing accuracy, optimizing product, and maybe customize according to the requirement, and visualizing, modeling, designing, all that can be done. And again, I just want to tell something about this to brief again. So we know now the product life cycle of a part or a product. So the first stage, introduction, growth, maturity, decline. The modern or the new, nowadays, what we are seeking by CAD to reduce this life cycle. That means reduce the introduction to market and the growth time reduction. And here it's we actually why we are trying to do this, because nowadays in competitively various products are coming to the market. So for an example, I Apple, they produce iPhones. From Samsung, they've produced Samsung phones. So they have competition. Once Apple produce a phone to the market, then quickly Samsung will try to produce a new model. So there's competition. So to reduce time for that, and the change the product always, because people will not like to use the same product for a long time. They may need new product with the latest technologies and improved product. So there are a lot of, if you consider about phones, like there are a lot of different designs. So earlier stages to design, long time back, maybe designing all marketing and like product life cycle maybe for 5 years. Now it's maybe only within 1 year we have to design, market, and then you will lose the market, the sales. So we are enhancing, we are improving the product, as well as we are reducing the product life cycle by use of CAD. So actually why we need CAD is, or the think of like a new factory, or these days we are trying to, first thing, we are trying to reduce the cost and improve the quality of the product, and reduce the time to market, or like manufacturing time, designing time, and maybe different customers need different designs. So the manufacturing system should be flexible. So that means different products can be produced in the same factory. Like we talked about batch production. So in that batch production, product varieties are different in batches. So like that, when you have to change the pattern or the design, production design, we can use CAD system to enhance the production time design. And you may have a question from here, so just remember what I said. So that is about the CAD. And let's see, I'm not going through this. You already know this, as I just told you. And there are two manufacturing methods: discrete manufacturing and process manufacturing. So in discrete manufacturing, you produce different distinct parts, different parts or products. In process manufacturing, you produce same type of product throughout the process. We talked about this as well. We use the term continuous manufacturing, or the continuous production process. So this is the same. So remember, these are two categories in manufacturing: discrete and production, the process manufacturing. And remember another term: sequential engineering and concurrent engineering. So in modern days, we are trying to reduce the design manufacturing time. Earlier, what was done, we identify the requirement or the problem, then we design it, and it's done by stages, like stepwise. So in, say, in a manufacturing facility, these are different departments. So in the research team, they will identify the requirement, and designing team, they will design, and also engineering teams, they will be manufacturing, and they will, another team will be doing the product verification, and maybe the other team will be doing some sort of maintenance of the product, quality control, likewise. So it's done by step. So this takes time in sequential engineering to manufacture and design a product. So nowadays, instead of that, using computers, it is easy to use a method called concurrent engineering. In concurrent engineering, all the teams, like designing team, manufacturing team, and the sales team, and the quality control team, they all work together as network. So for instance, like design team will design a product. In, as you see here, a design team will design a product, and they will send it to somehow to the manufacturing. So when you go to manufacturing, then there will be a problem in a design, so they have to send it back, reverse all this step by step. But when you're using type of concurrent engineering, they all work together here, so they can see what design team is doing, and they can manufacture, or like manufacture prototype and test it with, and same time give the feedback to designing, keep on, like together they can improve, because the different people have different experience, different engineering background. Now they all put in together as a group, as a one team. So this is concurrent engineering. So this is where we need computers. Again, here I told you there is a support manufacturing. If you consider a production system or the manufacturing system, there is a manufacturing support team, manufacturing team, and I will talk about this later on. So remember, as brief, this computer design and computers in design and manufacturing are used to reduce cost, improve quality, time to market acceleration, improve flexibility and customization, and use innovative technologies to improve the accuracy and quality of products. This is when you see computer. There's another system called computer integrated manufacturing. We have computer aided manufacturing, computer integrated manufacturing. In computer aided manufacturing, what we learn is how to use computers to enhance our production or the design manufacturing. In computer integrated manufacturing, also computer here when computer aided manufacturing, computer is externally support to enhance or improve efficiency. In computer integrated manufacturing, computers are in the system, so the machines are working use of computer, and the production is done controlled by using computer. So within the system, the computers are there. In computer aided manufacturing, we use the computer will support externally for manufacturing. So here, like what we learn in our course is this part. Actually, we can divide computer integrated manufacturing can be divided in two categories, and one is computer aided engineering and computer aided management and manufacturing. So we have CAE is computer aided engineering. What is this computer aided engineering now? We have, because we have different terms: CAD, CAM, CAE. So from CAE or computer aided engineering is also done by computer software. We can simulate, we can analyze, we can optimize the design to enhance performance, durability, functionality, quality of products. Also we can we can test quality, like how we do usually in traditional process. We make a prototype or a model and do the testing, but in say AE we can use computer simulation. We can model it on virtual like we call it virtual prototype. We can model it on computer and see all how loads are applied, and we do various kind of analysis like structural analysis, fluid dynamics, thermal analysis, allows to identify issues with this design and re-enhance the design. So computer engineering is a very critical component of design process, which is supposed to minimize the need of or the reduce development time and reduce the cost of kind of doing testing, making prototypes, and enhance productivity. So this is computer design and drafting, CADD, CAD. We use this term CAD alternative to this as well, computer design and drafting, or computer design. So actually the CAD, the computer design, is the overall work. Computer design and drafting is a category of computer design. So what is the difference here? In computer drafting, design and drafting, we consider only about drafting work. You may be knowing, like, maybe you have used already AutoCAD, SolidWorks, like softwares. So in AutoCAD we usually we are creating technical drawings. In SolidWorks is used to model. We model 3D products or the parts. Nowadays, like in AutoCAD also, you can model 3D parts as SolidWorks, but basically CAD or the AutoCAD is a drafting software package. SolidWorks is a modeling software package. Now actually nowadays both look similar. So what is computer drafting? It is, how we create engineering drawing. We have to take a paper and we need various tools and pencils or the pens, whatever, and we manually draw it. So how tedious that work is, how long it takes, and how difficult. And if you do a mistake, you have to erase it all and redraw. So that is a difficult process. So to improve that, we are using CAD or the computer drafting software. So how usually in computer drafting software, if I say the sequence, you already know this. From where you start is initially you set up, you do the, like, in settings, or like you set up dimensional units, what are the units that you are going to use, and what are the lines that you're going to take, and what are the paper size, what are the scale that you're going to use. Likewise, you do the setup, same as in technical drawing or the engineering drawing. You make a cage and you name the scale, whatever the parameters that you use. Like that you are doing in settings, you are creating the background setups. Then only you start creating geometry, like lines or these arcs, circles, or the square, whatever the geometry you will be drawing on computer. Then you usually apply dimensions for that. Then next stage, maybe you have to write additional notations, like include some text or symbols, or the label all the parts. Likewise, then once you are done with the modification or the design drawing, then you generate a printout, as that we call engineering drawing, or the CAD design, or the technical drawing. So in computer aided manufacturing is okay. I just go to the computer design. So here it's about drafting only, and computer aided design, as we discussed earlier, we identify the problem and we put it into the sketch or the model, and we will analyze, we will modify, and we will test it, and finally we send it here uh, to get the output printout or the CAD design. So now in software all these two are integrated. So once you do the model, you can generate the drawing as well. So just a second.